Now, here we're going to integrate the following using partial fractions. So how do we do this one? Well, the key idea is to firstly factorize the denominator. So let's take one point at a time. So let's factorize this denominator. This is a typical difference of two squares, i.e. the dots method. And to do this, you just square root both of these expressions and rewrite it as x plus 3 and x minus 3. Because square root x squared is x, square root of 9 is 3, and then plus minus on both sides. So this means we now have an equation which looks like this. So we have the integral of 12 over x squared minus 9 dx equals, and now this fraction is going to be something like the integral of, or let's say a something over x plus 3 plus something over x minus 3 dx. And that's it, guys. All we have to do now is figure out a and b is. So let's try it out. So we can now compare fractions. So we can say therefore that this entire expression equals this. So we can say, just working with the fractions, at 12 over, replace x squared minus 9 with x plus 3, x minus 3. This is somehow equal to something over x plus 3 plus b over x minus 3. Now the easy way to do this is to really just multiply x plus 3 across and x minus 3. So times in x plus 3 across, that cancels out, this cancels out, and we've got x plus 3. Times everything by x minus 3, that cancels out. This has x minus 3, and that cancels out. So hence we have a solution of 12 equals a times x minus 3 plus b times x plus 3. Now to actually get these values of a and b, just substitute some values. So let's substitute x equals, I don't know, 3. So you can say when x equals 3, what happens? On the left side we still get 12. On the right side we get a times, so we got 3 minus 3, so this is 0. So a times 0 is, well, 0, so this is all 0. Then we have b, and inside we got 3 plus 3, which is 6, so we got b times 6, which is 6b. So we're left with 12 equals 6b, and so dividing by 6 we're going to get b equals 2. Not bad. Now we do the same thing to find a. So, let's just pick another random value. So I'm just going to say when x equals, let's say 0, because easy. So let's rewrite the whole equation. So now on the original equation, we still got 12, so it'll be 12 equals a. So we got 0 minus 3, which is minus 3, so we got minus 3a plus, and now since b is 2, we can plug b back in. And then x, well, we said x 0, so it would be 2 times 3, which is going to be 6. There's other ways to do this, but this, you could just choose negative 3 to cancel it, but I like to choose a number and of 0. So solving this equation to find a, subtract 6, so you get 6 equals minus 3a, and find dividing by minus 3, you should finally get a equals minus 2. And that's it. Now all we really should do is plug this back into the original equation. So let me just make the pen a bit thicker. Okay. So what do we have? So we said that the integral can be written like this. So copy the integral, replacing a and b. So we can say finally that the integral now from a over x plus 3 plus b over x minus 3 dx, just checking if it's the same thing. Yep. Is now the same as the integral of minus 2 x plus 3 plus 2 over x minus 3 dx. So over here, integrating a linear function is easy. So anything, for example, the way this works, if you had to integrate, say 1 over x, this would simply just be log x. Now in this case, because it's a simple linear with no terms attached, the key idea is that you differentiate the term and you stick it in front. Because it's just x plus 3, if you integrate this, you copy the constants, it will be minus 2 log x plus 3 plus 2 log x minus 3. Again, differentiating this term will give you 1, so you do nothing to it. Differentiate x minus 3 gives you 1. And of course, plus c. And that's it, guys. This is the final result.